Okay, so today I want to talk about the unit circle. By the way, this is a re-upload. Well, not a re-upload, but a redo of one of my previous videos because I realized I made a pretty big mistake in that video, so I want to correct it in this one. So here we have the unit circle, all right? And I haven't filled anything in, but what is the unit circle? The unit circle is just a circle with a radius of 1. Now, what does that mean for the circle? Well, what is the formula for circumference of a circle? 2 pi r. In this case, r is 1, so that just cancels out. So that means this circle has a radius, or a circumference of 2 pi. All right? So let's go into what does it actually let us do, though. To do that, though, we need to label each one of these. Let's start with the easiest of them all, these 4 sides. So we can see based off the graph, we've gone to the right one, we haven't gone up and down at all. So we're at 1, 0. Up here we've gone up 1, we haven't gone to the left or right at all, so we're at 0, 1. Here we've gone to the left 1, haven't gone up or down at all, so we're at -1, 0. And here we've gone down 1, and we haven't gone to the left or right at all, so we're at 0, -1. So those are the easiest things to label. We've got those done with. And we'll get more into why this is helpful later, but let's just start with that. But now, we really want to label these sides, all right? But what are they? Okay, so this makes a 30-degree angle. This line makes a 30-degree angle with this line here. This line makes a 45-degree angle with this line here. This line makes a 60-degree angle. This line makes a 90-degree angle, and so on. I think you're starting to get the point. All right, we're just going to start with this quadrant here, and then I'm going to leave it as an exercise to the viewer to fill in the rest of this, but I think it'll be pretty clear on how to do that afterwards. So before we can start to actually figure out what the coordinates are for these points, we need to review our special types of triangles. All right, so we have the 30, 60, 90, and we have the 45, 45, 90. So I've drawn them both right here, so look at them real quick if you need to refresh this. All right, so let me grab a different color. Let's start with this right here. So I want to turn this into a right angle, and you'll see why in a second. So, and I'm going to, a right triangle. So that's going to be our right triangle. But I'm going to take it and let's draw outside of here. So this right here is our 30-degree angle. Here's our 90, and here's our 60-degree angle over here. All right, so we see it right here. Here, I'll draw that a little bit bigger so you guys can see it better. Okay, so let's realize this has a radius of 1, all right? Now, what is the radius? The radius means if I go from the center, all right, and I draw a straight line to the edge, that's going to be the radius. In this case, it's 1. So our hypotenuse is always going to be 1. That helps us out a lot. So our hypotenuse is 1. And this is a 30, 60, 90 triangle. So let's look at our 30, 60, 90 triangle. In the 30, 60, 90 triangle case, the hypotenuse is 2x. Let's divide 1 by 2, all right? And that'll give us the angle the side that corresponds to the 30-degree angle. So we have 1 over 2, all right, 1/2. Then we take x and we multiply it by square root of 3. So that gives us this side down here, which is going to be square root of 3 over 2. All right, so now we've found the measurements for this triangle here. But how can we actually figure out the coordinates based off this? All right, well, let's just realize that this means that along the x-axis, we have moved over what? How far have we moved over? We moved over square root of 3 over 2 over. So that means along our x-axis, it's square root of 3 over 2. right? Because we moved square root of 3 over 2 units to the right. And we moved 1/2 units up. Now, you're not going to be able to see this very well on my drawing because I'm not a very good artist, but this point is 1/2 of the unit circle. As the thumbnail, I will put a unit circle, a perfect one, as the thumbnail, and maybe you'll be able to see it a bit better there. But let's move on to this one right here. Let's do it, use green for this. So I'm going to turn this into a right triangle now as well. And I'm going to erase this and create more room for ourselves. So hopefully you can see I've turned this into another right triangle. Let's take that triangle out and put it out here. So over here we have our 90-degree, actually no, sorry. In this case, let me draw what it would look like. We have our, this here, and this here. No. Yeah, okay. That's correct. We have our 90-degree angle. And then, let's remember, we are looking at this 45-degree angle here. All right? So this is going to be 45. Remember, triangles have to equal 180 degrees total. So that means this is also going to be 45-degree angle. So what do we have? We have a 90, 45, 45 triangle. Let's look at those properties again of the 90, 45, 45. So let's remember, though, our hypotenuse is always going to be 1. Now, let's use Pythagorean theorem to figure out what these sides will be. So 1 equals a squared, and in this case, it's the same thing. The sides are equal to each other, right? So we can say it's a squared plus a squared, or 1 equals 2. So, 1 equals 2a squared. 1 over 2 equals a squared. That means a equals the square root of 1 over the square root of 2. Square root of 1 is just 1 over the square root of 2. But then we want to put the radical on top. So this becomes, we multiply both sides by the square root of 2, and it becomes square root of 2 over 2. So the hypotenuse is 1. These sides are square root of 2 over 2. So this means now our coordinates, we've moved both to the right and up square root of 2 over 2 units, all right? If we were labeling the coordinates of, if we move over 5 units and up 3 units, right, the coordinates would be 5, 3. So in this case, it's going to be square root of 2 over 2, comma, square root of 2 over 2. Now let's look at this 60-degree triangle right here. Oops, I want to use a different color for this again. Let's use purple. So, draw this down, create a right triangle. All right, let's erase this. And draw it out here. We have our hypotenuse that goes down. We have this. Here's our right angle. Here's our 60-degree. Here's a 30-degree, right? Because this has to be 30-degree because 180 minus 150 is 30 degrees. So that leaves that. So once again, we have a 30, 60, 90 triangle. So that makes it really easy for us. And once again, our hypotenuse is what? Our hypotenuse is always 1 because that is our radius. All right? Let's take a look at the 30, 60, 90 triangles again. And let's remember that the thing that goes across our 30 is 1/2. All right? Because it's x, our hypotenuse is 2x, so this is just x, right? And then this is our x value here times the square root of 3, or square root of 3 over 2. So then, remember, we have moved over 1/2 units to the right, and we have moved up square root of 3 over 2 units. All right, so that's going to be the coordinates 1/2, comma, square root of 3 over 2. Hopefully that makes sense to you. All right, so now that we have that, let's think. So the next thing I want to cover is radians. All right, so a radian, let me erase this before we start talking about that. A radian is just a measurement of an angle, just like degrees. But pi radians is equal to 180 degrees. All right? So if pi radians is equal to 180 degrees, that means like 60 degrees is equal to pi over 3 radians. All right? You're going to see this used a lot. You're going to see radians used a lot, so you should kind of get comfortable realizing, okay, well, if you have x pi over some other number, how many degrees is that equal to? And so you're just going to want to get used to working with that. Along our circle here, in terms of radians, here we have 0 radians, okay? Because when I'm talking about radians, I'm talking once again about the angle we are creating with this. We have 0 radians. And up here, actually, I think it'll be easier to start over here. Then we have pi radians, because remember, pi radians is equal to 180 degrees. This is a full 180 degrees, all right? So up here, then we must have pi over 2 radians. Down here, we must have 3 pi over 2 radians. And then over here, we also have 2 pi radians, or 2 pi radians. So 2 pi radians means 1 full revolution around the circle. And we'll come to understand what this means more when we look at the graphs of sine and cosine. But for now, let's just understand it. Now, I want to leave it up to the viewer to fill in the rest of these. But something that'll help you, all right, is once this line is also 60 degrees, this is a 45 degree, this is 30, this is a 30. Something that will help you is whenever you see a 60-degree angle, right, like this, or you see some x pi over 3, you're always going to have 1/2, comma, square root of 3 over 2, right? And then that goes when you have a 45-degree angle, right? Or that would be pi over 4 radians. You're always going to have square root of 2 over 2, comma, square root of 2 over 2. So that'll help you fill in the rest of this. And then once again, when you have some pi over 6 radians or 30 degrees, it's going to be square root of 3 over 2, comma, 1/2. All right, so now why does this help us at all, though? I mean, it's kind of cool looking, but why is this helpful at all to us? Well, say I come up to you and I tell you I want you to solve sine of pi over 3 radians minus cosine of pi over 4 radians. All right, and I want you to do this without using a calculator, okay? And I want you to give it to me in the best value you can without using a calculator. So the first thing that we need to realize is sine is equal to the y-axis. Now, why is this? Well, let's take a look at the triangle again. I'm just going to draw us a random triangle, right? And we have our hypotenuse of 1, right? And we're always trying to figure out this angle here. Now, this angle, remember, sine is opposite over hypotenuse. But in this case, our hypotenuse is just 1. So it's just opposite. And the opposite is going vertically, right? When it's going vertically, that is the y-axis, right? So that's why sine is equal to y. And then cosine, you probably guessed it by now, is equal to x. And that's because, remember, cosine is adjacent over hypotenuse. Our hypotenuse is 1 again, so it's cosine is just adjacent, and we're moving vertically, right, when we have adjacent. Vertically is just the x values. So now let's look at this problem again. Sine of pi over 3. All right, well, what is pi over 3 radians? Pi over 3 radians is 60 degrees. All right, sine is equal to the x values. Square root of 3 over 2. All right, then cosine of pi over 4. Remember, pi over 4 is that. All right, so pi over 4 is 45 degrees. In 45 degrees, our x value is square root of 2 over 2. So the best form we can leave it in is square root of 3. Square root of 3 minus square root of 2 over 2. That's the best form that we can leave that in. But so let me give you a different problem. Try to solve it on your own. Let's say we have, I'll throw a little curveball in here. I'll say 7 pi over 6 here, hold on. Sine of that plus sine of pi over 3, or sine of pi over 6. Now, when you try to figure this one out, just remember, all right, so now it's not going to be in just a positive angle, all right? So pi over 6, okay, pi over 6 is 30 degrees, and then the sine of that will be 1/2, but let's determine which quadrant will it actually be in, all right? Well, it's going to be in, is it going to be in the first quadrant? No, because the angle is greater than pi over 2. Is it going to be in the second quadrant? No, because the angle is greater than pi. Is it going to be in the fourth quadrant? No, because the angle is less than 3 pi over 2, right? So that means it's going to be in the third quadrant. In the third quadrant, sine is negative, so it'll be, in this case, negative 1/2. Make sure you identify which quadrant it will be in. So let's take a look. I'm going to erase this now. And let's take a look at the graphs. Let's start with the graph of, okay, let me draw out a little unit circle, a little baby one in the corner, because I think it'll help us out a little bit. So this is 1, 0. This is 0, 1, negative 1, 0, 0, negative 1. So let's start off with the graph of sine of x. So here we have pi over 2. Here we have pi. Here we have 2 pi. All right. Well, let's remember this is 0 or 2 pi. This up here is pi over 2. This is pi. This is 3 pi over 2. So, all right, let's graph just sine of x. So, along our x-axis, we have the angle the angle with this line here. Sorry, that was so odd. The angle with this line here. So, when our angle is 0, right? What is our sine value? Sine is y. So our y value is 0. So our first point is at 0, 0. hopefully that makes sense. Then let's move up. Let's move up to pi over 2. We're making a 90-degree angle with this line here. So what is our y value? Our y value is 1. Then let's move over to pi. At pi, what is our y value? Our y value is 0. All right, then let's move over to 3 pi over 2. Our y value here is negative 1. Then let's move back up to 2 pi or 0, and it should always be at the same as it was at 0 because they're equal to each other. So, try my best to draw this. So, that will continue to cycle. Now let's do cosine. Hopefully, you can kind of figure out how you could do cosine by yourself, right? Which I encourage you to pause, see if you can figure that out. 1, 0, negative 1, right? Once again, pi over 2, pi, 3 pi over 2, 2 pi. All right, so what angle is made? 0 radians or 2 pi. Then, in this case, our x value is what we're looking at because it's cosine of x. All right, our x value is 1, so it's going to start up here. Then we go up here, our x value is 0. Then we go over to pi, and our x value is negative 1. Then we go to 3 pi over 2, and our x value is 0. Then we go back up, and our x value is 1. So that's what our graph of cosine of x will look like as well. Now, hopefully, you're beginning to realize what really the unit circle is, what its uses are, and how it connects to this graph, as well as the sine graph. Probably in another video, I'll do how it connects to tangent. I'll go more in depth in tangent, and then the reciprocal functions, and then maybe the inverse functions. But hopefully you learned something new. If you notice I did anything wrong, please point that out. Thank you so much for watching.